Hello, Internet. Hi there. The last two sessions, we took a brief look at how things work in Unreal in general and how we do things in C++. Starting today, we're going to be putting these things to use because we're going to be building a small implementation of Conway's Game of Life. And if you have no idea what that is, or if you want to see how we do it, stay tuned. Yes, and here we are. A welcome to everybody out there once more, especially to the fine folks who are already with me here in the chat. Hi there. So welcome to the third episode. This is 2, 3. The third episode of the ongoing series. This sounds so cool when you say it like that. The third episode of the ongoing series, Coding for Unreal Engine in C++ here on the Devcom channel. And just as stated in the opening, the last two sessions, we just took a brief look about how things are done. How does Unreal work in general? Like how do you react to player input and all these things? What do you need to do? And how to get your own C++ code being executed as part of the scene or a game later on at all. And later on, we actually built a whole pawn actor completely in C++ without any blueprint help. Of course, we'll be doing quite some C++, because this is why we're here. But there's a few little pieces that we're gonna just be doing in blueprints because it's just so much more convenient and so much more easy. And considering you're working on a large project, you want to be a bit effective, you know. You want to take longer just because, well, I know we're doing everything in C++, but maybe if you guys are interested, the things we at first do within a blueprint for pure convenience sake, because everything can be done in C++. And it would actually be quite nice to, in the end, have something that's really solely done only in C++. There's not one single blueprint to be found in the whole project. That actually be quite neat. So if you guys are interested, if you wanna do this, at the end when everything works and we're happy, then we might do this. We might port over the few things we just did in the blueprint. We might port them over to C++ code. And again, just like you might have seen in the last two sessions, there's a reason why I say just do a few things in blueprints, because doing it in blueprint, you got like 2 or 3 mouse clicks to achieve what you want to do. And doing it in C++, you have, for every mouse click you do in the editor, you have to write one line of code, basically. So, yeah, but we can do that. And don't worry, the actor we'll be using, that will be completely done in C++. And we will do even one more thing in C++ than last time. But we'll get to that later, once we get there. Also, the code of the whole thing, while I'm working, the code that I'm building together with you here during this session, I will make it available once we're done publicly. So if for whatever reason you can't follow up or you don't want to, you just want to see how it's done and later then take a look at the code, you will be able to do this. The code will be available via Git. Not sure if it will be GitHub, maybe it will something else, but you can just check it out or download a zip or whatever. So yeah, there's something to look forward to that as well. So let's get the first question covered that some of you might have, because when I say we're going to be building a small implementation of the Game of Life, not everyone might actually know what the Game of Life is. I think most of you will, because it's kind of it's kind of a super classic in the computer world. It's super, well, when I say old, I mean, it's old. It's been done in the beginning of the computer times. There was a guy named Conway. I forgot his first name, shame on me. And he came up with this little neat thing. There's 4 very, very simple rules. And a bit later on, when we're actually writing the code to handle this, to process everything, and to calculate the next generation, we will actually take... There's a very nice Wikipedia entry that actually has a lot of truth in there, despite what you might about... Oh, I'm gonna check my cable here. Despite what you might think about Wikipedia. Otherwise, there's 4 very, very simple rules that define the whole game. And the game is, you can see it, I got the sample, a demo version open here. You got this grid. You got this grid of cells, and you can think about these cells just like living cells, like the cells in your body, the cells out there in, I don't know, the worm in the grass or whatever. And these cells can have 2 states. Unlike Schrodinger's cat, who has both states at once, these can only be in one state at one time, and they can either be dead, in this case, depicted by just being this little dot, which is actually a sphere, or they can be alive, which in this case is depicted as being a huge cube that you can see, because usually you do this actually in a grid, and then you just color the grid fields in your 2D grid, which are alive. The ones that are dead, you don't put any color in. And we can switch them. By clicking on them, I can make them come alive, and by clicking on them again, I can make them dead again. I can also look around, but this is basically, we don't need the looking around thing. This is just Unreal gives it this from the get-go, and I didn't like put it out or something. Well, because why? But I did a little something where we can actually move around. So because we will make the grid configurable, so you can actually change how large the grid is, and maybe it doesn't fit in your screen, then you can go back a bit and you can go closer to it. And yeah, we got those cells. We can have them dead, that's the little spheres or the dots, and we can have them alive, which is these neat little cubes. And then there's those 4 rules. Oh, Lakeside, hi. Greetings, go out. And your timing is perfect because we're just getting started. You haven't missed anything because you know what this is. So, yeah, hi. So, and then there's 4 very simple rules, and I try to quote them out of my memory. So bear with me if maybe I got the one or the other number wrong. When we start actually implementing our code, processing those rules, we will take a look at the Wikipedia article where those rules are stated, and then we will port them into our code line by line. So you got these cells, and if you have an alive cell, like let's take this one. You have an alive cell. This cell, to stay alive, needs to have 2 or 3 direct neighbors. So 2 or 3 direct neighbors, then this cell would stay alive. Everything would be cool. The cell would in the next generation, because you calculate the next generation by looking how are the current states and applying the rules. And this is basically the next generation. So this cell will be perfectly fine in the next generation. If there is more than 3 cells, the cell will die because of overpopulation. And if there is fewer than 2 direct neighbors, it will also die because of loneliness. Isn't that sad? That was the one rule. There's actually 4. Maybe I can't remember them all. As said, we're going to be taking a look at the Wikipedia article stating all the rules. One rule I just remember out of my head is when there's a dead cell like this, and you got 3 neighbors. This is a dead cell, but it has 3. I think it needs to be exactly 3 neighbors. Then this cell sparks into life due to reproduction. Yeah. And then there's 2 more rules that I have to admit. You know what? Let's just... why not just look up Game of Life? Life of Life, yeah. But thank you, Google. You already know what I'm looking for. And you can clearly see I've visited this link before. So, any live cell with fewer than 2 live neighbors dies due to underpopulation. Yeah, this was the one rule. When we have this cell and it only has 1 neighbor, basically both of these cells will die because both of them only have 1 neighbor, which is fewer than 2, and they're going to die because of loneliness. They are living a quite sad life. Well, it says underpopulation here in the actual text, but I think loneliness sounds a bit more dramatic. So, any alive cell with 2 or 3 live neighbors, this is the one I just stated, 2 alive, 3 neighbors, lives on to the next generation, so that cell feels perfectly happy, everything's good, and it continues to live its life. Any live cell with more than 3 neighbors, so it seems like I actually did remember all the rules, I just gobbled them up into one huge rule. So any live cell with more than 3 live neighbors dies, as if by overpopulation. No, so if you got like 4 or 5, whatever, it can basically have up to 8 direct neighbors. Since we're in a square grid, let's just we're in a square grid. So if you take any cell, you can have up to 8 direct neighbors, and most of these might die because there's just too much going on and they're buying too much toilet paper and all the others are not getting any toilet paper, and you know if you don't have any toilet paper, you die. So this is the reason why they die due to overpopulation. And then there's the last rule. Any dead cell with exactly 3 live neighbors becomes alive because of reproduction. So this is actually very interesting. In this world, you actually need 3 alive cells to reproduce and make a 4th one. It's a bit different like in the real world, where you usually have 2 neighbors that produce a 3rd one. Here you need actually 3. And then what you do is you go over your current grid, and based on the current states of the cells, you decide if each cell in the next generation is going to be dead or alive. And once you're through looking at all the cells, you just visualize that, because why else would you do all the math if you don't show the results somewhere? And if you continue doing this, if you're doing this in a loop, you're calculating the next generation, and then based on that generation, you're calculating the next one and the next one, always based on the current one. You get quite neat effects, because there's this one's particularly nice. But this one, I think you can see this one a bit better, for example. This up there, there, about there. This is actually Conway's Game of Life running and iterating through and calculating the next generation and the next generation and the next generation and so forth. And you can see, if you're a bit clever with placing your alive cells, you can have pretty neat effects. Like on the top, you have these things that look like they are going around, and once they collide, they spit out another little thingy that then moves across the board. And this is the fun thing. Oh, and it's 9070. not sure if is that the birth of John Horton Conway, by the way. So here it's made up for me forgetting his full name. He came up with this in 1970. So it's a 0-player game basically. Well, I would argue and say it's a half-player game because someone needs to set up the Genesis the generation 0, the generation with which it all starts. And yeah, you can see up here there's some very nice patterns that then have pretty neat effects. There's quite some well-knowns, by the way, and for those of you who are interested, I will just drop the link to this page into the chat. There's some that are stable, like this little cube of 4 cells. This is stable. It just never changed. None of them die. None of them come alive. They will stay like that for infinity because all of them have 2 or 3 neighbors, so they don't die. But any others don't have 3 neighbors, so they don't come to life. Same with these. So they are stable ones. And then there's the Wikipedia article calls them oscillators. Back at home when I still lived with my parents, because I was first introduced to Conway's Game of Life by my father. Thank you for that. We called them blinkers because they are blinking. They are blinking. Like your classic blinker. They are changing between 2 states. This is the very, very, very absolute classic one. This is the 3 cells either besides or on top of each other, which just switch around. And then there's the other ones. This one looks particularly nice. Oh, this one is actually changing between more than just 2 states. This one's nice. This one's an actual blinker, like on your car. This one's pretty neat. And I think we're going to be, once we're done, we're just going to be playing around with this a bit and actually reproducing these patterns and these thingies to see if everything works. And then they call it spaceships. I know them as movers, but it's pretty much the same thing. This is these little guys, because they are moving across your grid. They are kind of stable because this how do we call it, collection or I don't know, we need a name for that. This collection of cells never dies out completely, but with reproducing and dying off, it moves over the grid by constantly changing its shape and following the rules. They move, which is pretty nice. And then you got like these super complex, and there's an animated version of that. Let me see if I can find it, because that one's particularly nice. I know there's there's a link to animation. Here it is. And let's get this a bit larger. Because this, I think it's quite complex to set this up. But you can see you have this huge swarm of cells that also moves through the grid and leaves these other thingies in its wake that we just saw as a separate, shall we call it, animation, which then again shoot out these little tiny spaceships that then move across the board. So there's quite some stuff that can go on in Conway's Game of Life, and this is the thing that fascinates me the most with this. Because all of this, what you can see here in this animation, the whole thing is just those 4 rules. That's it. It's only those 4 rules. And this is also the reason why I like to give this. I think this is a very good project if you start coding, if you're learning. I think this is the step after when you're done with your Hello World. And you got a bit comfortable and you also did a Hello World that says your name or something like that. I think this is a good step too after your initial hello world, because the underlying logic is not that complicated. It's very, very simple, and you got to work with arrays. Or we won't be using arrays. We'll be using maps. We could use arrays, but I personally find maps are a bit more versatile. They are much more convenient to use. But we'll be there quite shortly, I think. So, and this is exactly what I'll be building with you in the next. Not sure if we make it within 2 sessions like tonight and the next one, or maybe it'll take us 3 sessions. But I think both is fine. And this is what we're going to be building. And as said, you can the goal is that you can toggle these cells just by clicking on them. You can either make them dead or alive. Again, not both, but that will be neat actually. Maybe we find a way to give them the third state dead and the Schrödinger state. And then you hit enter, and the whole thing starts iterating through all those generations. And you can see that there's the little spaceship, the mover, that crashed into the cube down there, and it kind of exploded. I think it looked quite nice because it really looked like it crashed into the asteroid and then explodes, which comes back to the spaceship thing. And there's also the blinkers up here. Let's restart this and over the other one. I think one started like this, and I actually really like the mover crashing into this thing. So let's see if we can do that again. And hit enter to have it running. And you see this thing's blinking between 2 states, and our little spaceship here is crashing into an asteroid and just gone. Yeah. So this is what I will be building with you. So let's get started. First thing we need, and I prepared just a little bit. Don't worry, I didn't prepare any code or anything. Well, I did in my notes, but now I need to find the right windows. And my chat window, most of all. There. So I can see you if you say something. What I got here is an empty scene. I got when you open up Unreal and you have your starter content selected that you want to have starter content, you got the table and the chairs and everything. And I just took this starting scene and just deleted the floor and the chairs and the table. I just deleted that out of that. So we got the rest. We got the sky sphere, and we got a bit of the lighting and everything that's set up in this little startup scene. And from here we can start. So the first thing we need is an actor. And we know this because we've built an actor in C++ last week. So let's do this again. Let's say we want to create a new C++ class. I think a normal actor will be okay because the little cells, each cell you just saw in the demo of what we're going to do, each cell is a separate actor. Maybe I can show you again if I get this over here once more and start it again. You can see here's lots and lots of cell actors. And if I eject out of the player controller and I just select one, you can see these are the cells that we played with, that we had dead and alive. And every cell is one separate actor. So it's one actor that we wrote or are going to write, and it's instantiated or spawned. It's spawned multiple times wherever we want. And this actor has actually all the logic. Like when you click on it, that it changes between the cube and the little sphere. Because if we go closer to it, you can see that when they are dead, they are these little spheres. And when they come to life, they become these huge cubes. You could basically put in there whatever you want because those are Those are just static meshes, and I just took the cube and the sphere from the starter content. You can make up whatever you want for there. My Crins, hi there. Is it possible to see the sessions later? Yes, this will absolutely be possible. Just popped in and sounds very interesting, but you missed the lessons before. That is no problem, because all these sessions, for one, they are available as VODs on Twitch. So if you want, and if you're within the 60 days time frame, these are usually kept. You can watch the VOD on Twitch, no problem. But they are also put on YouTube. And is there? Oh, and there's. Look at that. There's the link to the YouTube channel. This is great. So yeah, you will be perfectly able to watch this on YouTube whenever you want. And if you have any questions, there's also right above me. There's the hashtag Ask Devcom Tutorials. So if you're watching the videos and you have any questions, whatever, something was unclear, not well enough explained, or something wasn't covered at all, just tweet at the hashtag. And I will see that we got the question covered. Just started your training as a programmer. Nice! Yeah, then if you just started training as a programmer, I think this will be hopefully very helpful, because I try to explain everything, also the basics, so I don't expect you to know much about what's going on already. And as said, if there's any questions, the only stupid question is the one not being asked. So please do. All right. So yeah, these are our actors, and they have all the code and all the logic, so they can become little spheres or larger cubes. So let's see how we do that. So first we need our C++ class. And this is what I was just pointing at, because I showed you this again. We only need a normal actor. We don't need an actor pawn like we did last week, because these actors, even though the player is interacting with them, they are not directly controlled by the player. Again, the difference between a simple actor and an actor pawn is the actor pawn is more the one actor that is actually the player. Like if you're in a first person game, you don't see much of it usually, but there's the actor bearing the camera and having the controls to move around and everything, or in a third person view, or any other basically. It also has the mesh that depicts whatever the player is playing and running around with or moving around with. It might be your spaceship, it might be the actual character that's walking around or something. And we don't need that, because these are not directly controlled by the player. The player is only interacting with them. So we pick an actor class and we call this cell actor. It's also good practice. I think I mentioned this before. It's also good practice to always suffix your classes, and this goes for C++ and for blueprints alike, to suffix your classes with what it actually is. So in this case, it's in cell actor, and we'll also be doing a component later that has the handling code to actually place and spawn all these actors at the different locations, or the correct locations. We'll be doing this as a component for two reasons. Because A, convenience, and B, to have something different, to not only have an actor, but also to do a component like we did in the first session, to use pretty much everything we did so far. Since in this directory, in the main directory that Unreal creates for us, there is a few files already in there, which is those. So I actually would like to put it into some kind of subdirectory. So we have all the stuff we did ourselves directly in a nicely sorted away from everything that's automatically generated. Because here's a bit of stuff in there. There's like the game mode base. We'll be coming back to this later. At first we will create a game mode, because we have to create our own game mode for this, to be able to for the clicking and the mouse handling stuff. But I'll explain it when we get there. But yeah, we'll we have the game mode here, and we have a little of other basic entry stuff. So to not put our own files somewhere among these and then have to which is ours, which is the other generated stuff, I actually do want to put them into a separate directory. The problem is, what are we going to call this directory? Because we have, I'd like to call it game, because that's where our actual game code is in, but then we already have games, and then we have a game folder and a game, so I don't know. Call it game of life is also a bit redundant. So how are we going to call this? We could call it like something like, see, this is one of the things you should think up front, because in my notes I put this into a different project where I just could, you know what, we just call this game. We just call this game, or the game, or whatever. I mean, we're free. We can rename these. It's no problem to rename these, because for the C++ files, they really don't care where they are. There's programming languages, especially Java. For C# and Unity, it's also, yeah, they kind of don't care where they are, as long as the file name is identical to the actual class name. And C++ files, they really don't care. They don't care what the name of the file is. They don't care where the file is, because all this information is lost when it's compiled. Unlike C# or Java, that still knows the directory structure of where everything is and the names of where everything is, because the little runtime code that actually, when you create a new class, or an instance of a new class, that knows like, oh yeah, okay, you want that object, I'm gonna grab this from there, determines this a bit on the paths, and especially the name of the file. And since C++ is just compiled into one huge binary that's just executed on your CPU, it really doesn't matter. So we can rename this if we want later on, but for now, to just have a nice directory where I can actually put our code into and not have it mixed with all the pre-created stuff from Unreal, we just put it there. So we got a cell actor. Just wait a bit, because it creates the skeleton actor C file and the header and a few other things inside the C++ project, so that our IDE later knows what actually to do with those files. And here we go. So this looks familiar. We already know this. We've already seen this. So, fill out copyright notice in the description of your... We could do this. You know what? Let's quickly do this. Let's go into project settings, and here it is. Fill out your copyright notice, and this is let's make the copyright sign. I like it. 2020 Devcom Tutorials, right? This looks nice. Dadla, hi. Greetings. Nice for you to stop by. Hope everything's fine on your end. So yeah, and since this is missing from here, this will be the one or the two files where we just put this in manually. And when we create the next file, and there will be a next file we're going to be create, because as I just said, we'll be creating a component as well that will then handle and spawn all the actors. This will be automatically put in up there. You will see the magic. So let's clean up this a bit. Let's just delete these comments, because they are always the same, and by now we know what they're saying. Also these surplus empty lines, let's get rid of those. And again, there's 2 blocks public. We don't need that. I think 1 block public is enough, but we can make this private already, because there's I'm pretty sure there's a few things we'll be putting in there. So let's clean up this so more of the actual stuff fits onto the screen. AI Chatbot, hi. Nice for you to stop by. Greetings. So now we got an empty actor. If we would pull that into our scene, basically nothing would happen. So we need to make things happen. And you remember from the last 2 sessions, if we want an actor to actually look like something, so you can see it, you need a static mesh. And for a static mesh, you need a static mesh component, so that you can tell this component which of the meshes you actually have in your project it's supposed to show. And if you do it in the editor, if you have like you create a blueprint, we can neatly add your static mesh component. You can just in the editor select it, and we have to do everything by hand. Remember, this is what we did last week, and so we're just gonna be repeating that. But I'll be peeking into the chat first. Uni, I was looking for just for Access Gamescom 2020. Well, you found the right place. This is part of Devcom is actually part of Gamescom. Devcom is the developer conference of Gamescom. So you're kind of in the right place. But yeah, there's also the games. I'm not sure if the actual Gamescom channel is live at the moment. They might be, because they are live pretty much recently. Because, well, it's not too long till Gamescom should have been. Well, it kind of is. It's just digital, virtual. But yeah, hopefully, I really, really hope that next year we'll be having a physical Gamescom again, because I miss it. I already miss having and going to Gamescom. And Dada says, Game of Life sometimes turns to Game of Death if all cells die. That is correct. I typed a listing, so he typed a listing on a C64 when he was young and tried different starting cell combinations. Yeah, I spent days with just coming up with different patterns and cell combinations and stuff. Yeah, I spent my fair share of time of trying out what works and what works not. And at least for me, I quite often hit a combination that would just die out. Either they would all die and the field would be completely empty after that, or most of them would die out, and in the end you'd have like a few stable combinations that will just sit there and do nothing. But yeah, all these things we can try out once we've done this, and we can see just on the Wikipedia article I just took a look with you. There's some patterns you can use that actually produce already quite nice results, and well, we're gonna try them all out. So back to our actor. We got our actor here, and yeah, remember last week, we need to create a static mesh component that we can put onto our actor. And for that, we need a root scene component, because by default, there is none. this actor now is really, it's completely empty. It doesn't even have a root scene component. It might work putting this into the scene, but it will absolutely do really. If it could do negative things, it would do a negative amount of things. So little does it do. That program ran slow on the CC for and there's a lot of calculations. We're kind of about to see it. I'm not sure if we get there today, but at least next time, the latest, we will be seeing. You have to check all 8 neighbors for each and every cell. You have to check all the 8 neighbors. Maybe there's a way to optimize this to make this faster, which would be interesting if you run it on a C64, because there you could actually see if your changes in the algorithm and the checking of the neighbors, because we're doing it pretty simple. We just have our cell, and we just go the whole square of all the 9 cells with ours in the middle. We just see and count the live ones, not counting the one we're actually processing right now. So yeah, there's an idea for optimizations. So first we need to create a root scene component we can attach more things to. And how did we do this? All hail the auto completion. There is all, because we're not starting absolutely completely from scratch with an empty file. If we take a look in the header, we can see we're extending the base actor class that Unreal supplies us with. We're not starting with absolutely nothing. We already have everything the basic actor of Unreal has and supplies us. And one of the things that is we got a property of our class, our object, once the class is instantiated. I'm not sure if there's here. I got a question for you guys, and you just have to let me know, because I said I'm not expecting you to know too much about programming and everything. Mealtime! Ref Road Best, hi! So, you're gonna be eating. That's good. Fortunately, I've already eaten, so I'm perfectly fine. Hi there. I said that I don't expect you to know too much, but there's one thing we haven't talked about. We talked about a few basic things. We talked a little tiny bit after pointers, and I think I promised you that we go in depth with pointers, and I think we will be doing this once the Game of Life thing is done, once that's running, and the evening after that we'll be focusing and talking a bit about pointers and trying out stuff with them, and I think we're gonna make the engine crash really bad, really like nuking. It will completely crash away. We have to completely restart it. Fortunately, these days, not the computer, only the engine. But there's one thing we haven't talked about, which is object-oriented programming. Like, what does it actually mean? We are extending this class, and what's a class, and when is a class an object, and why is my object not a class, and vice versa. We haven't talked about these things. If you're not familiar with these things, please let me know. Either when you're here live on Twitch, put it in the chat, or if you're watching this later on YouTube, put it in the comments, or tweet at the hashtag you see above me, hashtag Ask Devcom Tutorials, and just let me know if you need a brush up on how object-oriented programming works. What's a class? What's an object? What's inheritance? What's extending something? So if some of you have a problem and I'm not familiar with this, so I can see that we got this covered somehow, because this is quite important, as you can see now, because we're using things we we didn't create anywhere. So we're actually, this is because we're extending this. On the C64, there's a rule: directly programming the machine, never run before save. Fortunately, here you can't run it without saving, because to actually make your code run, you have to compile it. And for the compiler to compile your code, it has to read the files where your code is in, and it can only do this if you're saved. So the rule is absolutely true. The rule is still true. Never run before save. That rule still applies. But by the way things work, it comes automatically, because you can't run it without having it saved. Because if you didn't save it, the compiler can't compile your code, so it won't run. So yeah, this... but yeah, you can't... Unreal also has... because when you're actually... Okay, this, what I just said, only applies to our C++ code. When you're working in Unreal and you work with blueprints, you can actually use them without saving. You can do things and logic and visual scripting code in your blueprint, and you can run it and you can try it and it works without having the blueprint saved. Unreal has autosave quite regularly, so if something bad happens, you're losing like, I think, 10 minutes tops. So it's not the end of the world. And bad things can happen if you call a C++ function from your blueprint that, because of a bad pointer or something, makes the whole engine crash and go away, because also the editor just says, okay, I'd have it, bye. And you haven't saved your blueprints. Yeah, with blueprints, this could actually happen. So there's when you're working with blueprints in Unreal, you got two buttons. You got the compile blueprint button and you got a save blueprint button. Always hit both of them. Always do compile and save. Then you're safe. So we got our root component here, and we got our wonderful function create default sub-object. This is so nice when the auto completion kind of knows what you want to do, and what you're looking is quite at the top. Create default sub-object. This was it's an Unreal supplied function that we give it a class, and Unreal knows that there are special things to do to actually create an object from the class that does what it needs to do. Because there's with those special things like scene components or static mesh components, there's a bit more to them than just creating an instance of that class, just instantiating it and creating an object. There's a bit more things that need to be done, and this function knows all the things that need to be done. So instead of just saying, yeah, root component is a new scene component, we use this one and tell it we want the default sub-object. I'm not sure why it's called sub-object. One of these days I'll actually do a deep dive into the documentation, or maybe even the code, to see why it's the default sub-object and not just the default object. Well, this is the magic. These are the specific things of Unreal. So what's going on in the chat? Since Dana is a proper beginner here, basically just copying what I'm doing here for now. Confession. Been doing a bit of reading because you're a nerd. That's nice. That's good. Nothing to confess about. But if you're into any problem or you're lost, you will let me know. Nice. Please do. Please do. I mean, you know where to find me. You have so many ways to find me. I mean, we're on Stefan's Discord. So you can also just drop me a line there. No problem. And on .c64, wrong poke can overwrite your program code. Yes, this happens in a loop program can be destroyed. Yes, self-modifying code. This is an art style. And yeah, I kind of do consider this a bit to be a bit of an art style. Self-modifying code. It's something that doesn't work on modern CPUs because of caching. So you unfortunately can't do this because self-modifying code can be really fun. You can do a lot of wrong with that, and I don't know, maybe that's what makes the fun. But yeah, code that actually modifies itself by writing, or in case of the C64, doing a poke, at the address, at the memory address is where the code itself is, and then putting other things in there, so kind of exchanging the commands. Yeah, that's fun. Yes. So again, we can, if you want, and we should give this a name. I have still not figured out why that name is not actually shown in the editor, but maybe eventually it will. So we call this our actor root component. And maybe we do this with a lowercase o, so it looks a bit more proper, you know. So create default subobject creates a proper initialized and working object of the scene component class. Again, prefixed with the u because it's coming from a u object. Because again, in Unreal, we almost never use default types. So we don't use just an object, we don't use just a string, we don't use just an array. We're using U objects. And the U stands for Unreal because remember, all the prefix, the first letter, always tells you a bit about what type, what kind of type this is. So we're using U objects. We are using like T arrays, and the T I think stands for type, because they are typed arrays. You can tell the array if there's strings in there or numbers or floats or whatever. And yeah, this one way down at its rootest root comes from a U object, so that's why the U. And also, if we make our own component, when later on we're going to be doing our own component, this will also be prefixed by U. Like, look, the actor is prefixed with A. We called our file cell actor. Remember when I said I want to create a new C++ file and I wanted to be an actor? I said, yeah, let's call it cell actor, and it's prefixed with an A, which tells us that this class, this comes from the actor class that Unreal supplies. So this is an actor plus something on top. So it has an actor at its root, which tells us a bit about the things we can do with it, functionality it supplies us, and same with the U. But the U, it doesn't really, it only has basic functionality that is about handling objects, mostly used by Unreal itself, especially the dreadful garbage collection. And we'll be coming to that. And I think I'm demonstrating you how the garbage collection can actually kick you in the butt in ways. Your program crashes and you're looking for the bug why it crashes for a whole day, and at the end of the day it's just been the garbage collection that thought, oh, what's this? Is this art or can this be thrown away? Well, then it decides to throw it away. But for you, it was art, so you wanted to keep it and you wanted to keep using it, but it was thrown away, and you can't use thrown away things. It's just like with your toys. If you got your favorite toy and your parents threw it away, you can't use it anymore, right? So we got our root component here. What else do we need? Because so far we do have a root component that basically does nothing but being our root. So one more thing that we need is create the static mesh component so the actor can actually look like something. And see, my IDE even informs me about typing mistake. I completely messed this up, right? Yeah, okay. Not sure what I did wrong there. I think just everything. So, we're going to be having a static mesh, which we don't have yet. This is why this is red, because the root component, this is a property or a variable of the class, depending on how you want to call it. This is a property that exists because we're extending the actor class of Unreal, and this has, I'm not sure if that makes sense if I try to find it, but yeah, there it is. See, this is actually the header file of the actor class, and you can see here that there's a lot of stuff in there, and there's also a protector property which is the root component. So this exists because it exists in the actor that we're extending, so we can just use it. But there's nowhere ever a static mesh property created. So maybe we should do that. And we do this. Let's do this publicly for now. So we're gonna be having a static mesh variable property, and that will be of the type, what is it? I think it was static mesh component, right? Static mesh instant static mesh is a nice thing. Maybe one day we get to talk about this, but here it is. Static mesh component. This is exactly what this is supposed to be. And now we just do it properly because this won't work. This won't work. Again, remember, the static mesh component is an instance of a class. So it's an object because we're having object-oriented coding here. This is an object. And remember, in C or C++, we can't store a whole object in a variable because all variables, since C code is actually directly seen by the CPU and executed by the CPU, everything has to be in a way so the CPU can actually understand and handle it. And the CPU can't handle large, complex objects that are quite high level. The CPU has registers. On most modern machines, these are 64 bits in size, and that's it. So we're not putting a whole object into this variable, but we're putting the address where all of the object with all the functions that it offers and all the values it holds. Once we instantiate it and we have the object, it's somewhere in memory. In all the gigabytes of your memory, there's the object. And here we'll be storing the address. So a pointer. And yeah, we'll be talking about this eventually. A bit more in depth. So let's put the asterisk there. So because we're getting from the create call, we're getting a pointer back, and well, as explained, we're only putting the pointer in here. So we have to put this little asterisk here so the compiler and everything else knows, okay, this is a pointer to something, and this is a pointer to an object that's of the type static mesh component. And you already see the yellow squiggly line here. So we just do this properly, but once everything works, I will remove this just for demonstration. Not sure if I'm not sure if this will crash, but it could crash. You see the yellow squiggly line here, and when I hover over with my mouse and I try to get this a bit larger, you see my IDE that is very clever and knows a lot of things. Already tells me, hey, dude, your object member, which is another word for the property of my class, static mesh can be garbage collected at any time. Which means I'm creating an object in my code, or I'm about to. I will create, or we can just do this. Wait, we already have this defined. Let's save the file. So we have it here. So we will be doing create default sub-object here as well. And maybe I get all those brackets right. And again, oh yeah, and don't forget any text that's supposed to be shown anywhere. And if it's just in the editor, you have to use, this is something Unreal absolutely wants you to do. Any string that's supposed to be a text that maybe at some point be shown in the editor or the engine to anyone, you have to use this text macro because this does a few things with your string, with your raw string, to make it into a textual string that makes Unreal totally happy to be using. Yeah, I hope that makes sense. And will be static mesh component. Static mesh. There it is, static mesh component. And this is basically it. Just like with our root component, we're using this Unreal supplied function to create an object based on the class useStaticMeshComponent, because that's what we want, and we can give this a name. We can EctorMesh. Let's call this EctorMesh. So, and this gives us a pointer to the created object, and we store this in our property in our class member static mesh. So, engines like Unreal Engine or Unity, or there's so many, or even just languages like Java, and it doesn't have to be a huge game engine. There's languages who already have this. Java, for example. Garbage collection. And garbage collection sounds a bit like the huge garbage truck that once a week stops by your house and takes your garbage can, empties it out, and drives away. And this is basically exactly what it is. The garbage collection, every now and then, takes a look about everything. And it asks the question, is this art or can this be thrown away? And when the garbage collection doesn't deem whatever it finds as art, it collects it and then throws it away. And then it's gone, it's dead. In case of an object, this means it's actually destroying the object. So this is like, exactly. Ist this art or can this be thrown away? Ist das Kunst oder kann das weg? And if you're unlucky, it kann weg. Yes, exactly like that. In case of an object, this means the object is completely destroyed. This is like one of my favorite examples how classes and objects work. The class we are writing here. This is a class, a C++ class we are writing. This is kind of like the blueprint you give to an architect. And the architect builds you a house based on this blueprint. And the house is what in this programming world is our instantiated object. It's what we're getting back here. Our created object is basically like the house. So once you created the house, once you built the house based on the blueprint, or in other words, once you created the object based on your class, you can use the house by going in there and using the bathroom or whatever. In our world here, we can use the object by calling its functions, by accessing its values. Destroying the object would mean destroying your house. Tearing down your house and put grass on the big hole and filling the big hole just with grass again. Once your house is destroyed, you can't go in there anymore because it doesn't exist anymore. And this is the very same with objects. When an object is destroyed, you can't use it anymore. You can't access it anymore because it's gone. Now you might think, yeah, but we only have the address where it used to be in memory. So maybe we can, I don't know, there's still a ruin left. There's whatever was in memory of the object might still be there. If you're super duper hyper lucky, then yes. There is a very, very, very small chance that 1 or 2 calls to a destroyed object still might at least not completely crash your program. But the memory area your object was stored in is also considered free again. So it will be used for other things, other stuff. Other things will be put into your old memory address you had there. And then one of two things could happen, or at least one of two things could happen. Or one of at least two things. I think this is the correct. One of at least two things could happen. Either the engine or at least the operating system notes that or notices that you're accessing an area of memory that you're not supposed to be accessing anymore, because modern systems keep track of who reserved what region of memory. And the operating system, or maybe even the engine, know that the memory address you're trying to access here, because you stored them when you created exactly. Douglas knows exactly what I'm trying to talk about. It's an access violation. The system knows that this memory area doesn't belong to you anymore, because whatever was there has been destroyed. The memory has been freed again. It's available for someone else, or maybe it's even taken by someone else. And then you get exactly what Dudler just said. You get an access violation, because the system knows you're not supposed to access this region of memory. So I'm gonna be stopping you here, and I'll be stopping you here in computer terms is you got shot in the head, because your program it just crashes. It goes away and never comes back unless you restart it. That's one thing that could happen. Or, just for argument's sake, let's say you're not getting an access violation. For whatever reason, you're actually allowed to access this memory. But now there's garbage. Yeah, I know. The garbage was supposed to be collected, but garbage collection is a messy business, so sometimes there's garbage left. Because your object is handled by the runtime, by some magic in the background that takes care about your objects. And this object has not been taken care anymore of. It's digital garbage. And so you might, if you try to call like a function on the object, on the address where the code for this function used to be, there might be other stuff. There might be some other bytes that have been written there, or something happened to that region of memory. So there is no proper code to be executed anymore. There are no valid values you could access, which in turn will also make your program crash. So TLDR, whatever happens after an object is destroyed, in 99.9999999% of all cases, it will make your program crash. And if a C++ program crashes, it's completely gone. So even if you have this huge, and I have this huge Unreal Engine, and there's just a little piece of my code that does something wrong, the whole engine crashes because of your code. So you do have a huge responsibility while writing your C++ code, because do one thing wrong and the whole engine explodes and goes to ashes. Which I think is kind of cool in a way, you know? Because you don't only have the responsibility, you also have the power. So, and all this long and exhausting talk, well, exhausting for you maybe. I actually enjoy talking about these things. And you didn't yell stop in the chat, so you didn't stop me. It's on you. we got the object, and this is actually the warning we're getting here, because garbage collection could take away our object at any time. And then we're lost. Then it's gone, and it'll crash, and we don't have a mesh anymore. We don't even have a game to play anymore. So what can we do to prevent the garbage collection from not destroying and putting our object away? There is several ways, there's several things you can do. The easiest, and also I think the cleanest and best way, is just to declare this as a U property. That's it. You don't even have, remember, when we did things in our C++ code that we wanted to be accessible from blueprints, we could put stuff in here like edit anywhere, or blueprint read write, or blueprint callable. Well, blueprint callable is for functions, not for properties, but I think you get my point. We don't have to put anything in here. It can just be an empty U property decoration. So Unreal Engine now knows that it has to take care of this. Without this, Unreal Engine doesn't really know that we do have this object. So it doesn't know if the object is still being used, because the way garbage collection works is, when I said it's checking if this is art or if it can be thrown away, the decision if it's art is based on if this is this thing still in use. To stay with the art analogy, you can put it like, it's a painting, and are there people currently looking at this painting? Are there people that look at this painting? There are two people looking at this painting. It's art. We keep it. Eventually, these two people go. The painting is still there. It still takes up valuable space on your wall, but there's no one looking at it anymore. And then the garbage collection sees this and say, oh, there's a painting, our object, and nobody, 0 people are looking at the painting. Or again, in computer terms, no other piece of code is using this object anymore. And that is the moment when the garbage collection says, okay, I'm going to be pulling this down and throwing it away. But we are using it. We are using it here. It's our static mesh that we want to be shown for our actor. So we need to give Unreal a way to take track of us still using, of this object that's stored here still being in use. Because if we do it like this, Unreal doesn't know. Because this is just a pointer stored anywhere, and Unreal has no way of knowing that we still have a reference, a pointer, to the object, and we're still using it. So what we're going to do is we put the U property here, because now Unreal knows, this guy there, here, he is still looking at this object, because he has, now Unreal knows that we have a reference to this object, that we are still looking at the painting, and Unreal can keep track of these things, because there's quite some magic that's behind this U property thing. There's quite a lot of stuff going on in the background, and one of these things is that Unreal can keep track of us still having this pointer, this reference to this object. Should this actor wait, gotta moisturize my stomach, my throat a bit. That means enough people look at the Mona Lisa, because it still has not been garbage collected after hundreds of years. Exactly. And go to the Louvre at any day, at any time. There is still someone, there's always someone watching. And be it the security camera in the corner of the room, that counts. That counts as watching. So yeah, it's not garbage collected because it's still being observed It's still being watched at. Exactly. Should our actor be destroyed? So it's despawned. Well, for whatever reason, the actor is destroyed. Then, since Unreal knows due to this and keeps track that our actor is still looking at this object, Unreal now knows, oh, this actor, this object, this program object is gone. And if that's gone, also this reference is gone. And since Unreal is tracking it because we made it able to track it, or we told it to track it, it knows, okay, this reference is gone. And then the garbage collection can actually destroy and put away our static mesh component, which is okay. And indeed, actually what we wanted to do, because when this actor is gone, when this object is destroyed, we don't need the static mesh component anymore in memory. That would be a waste of memory. So it actually can safely be put away. And Unreal can, if we declare this as a U property, Unreal is able to keep track of all these things, so the garbage collection doesn't steal us our object. The garbage collection actually knows we still want to look at it, we want to be using it, and it leaves it alone. So just by putting this U property in front of it, the garbage collection works like we actually want it to work, and prevents our static mesh or whatever. Well, there's will be some more we're going to be putting in there. This thing is not be destroyed. So, hey, Hoppelsbock, grüß dich. Hi, schön, dass du reinschaust. Wir programmieren gerade ein bisschen. So now we got our root component, and we got a loose static mesh component that's just floating in the air, not bound to anything. And now we're doing something different, because remember last time we created our static mesh component, and then we had to drag our actor into the scene. And it still didn't show. It was there. It was in the world outline. It was in the list of things that are in the scene. But you didn't see anything, because while we did have the static mesh component on it, the static mesh component didn't know what mesh to display or to show, because we hadn't told it. And we were like, okay, but now we can, when the thing is in the scene, we can, in the editor, select our static mesh, and that's it. We can't do this for two reasons. The first reason is because we want to do everything in C++. We do not want the editor in any way to be involved with the creation of our actor. So we want to do everything in our code. And the second reason is it would actually make things a bit more complicated, because this actor, unless the actor from last week, we're not just pulling into our scene and then it's there and then we can select a mesh in the editor and everything's cool. This actor later on will be spawned again by additional code. We'll be writing, when we come to the component, we'll be writing, this component will actually take care of spawning all these actors. And then you would have all these actors that don't really visually show, because for each of them you'd have to select the mesh, and when you restart the game you would have to do it again. This is not really feasible. You could have one instance of the actor somewhere in the scene and give a reference to that, to the spawning routine, so it can spawn copies of that, but that's also not nice. So today we're actually gonna be assigning the mesh to be shown right here, right in our code, after I said hello to Frankenstein. Hi. Welcome and thanks for joining. So, Hoppelsbock hopes People are not melting. Yeah, it's getting warm in here. It was actually quite comfortable here during the day, but now with all the computers on and the additional light on, because eventually the sun will go down. So I already turned on the lights. So when the sun goes down, there's still enough light for the camera to see me. But then again, you should look at the code, not at me. It starts getting warmer. Yes. But it's supposed to become really warm during the weekend, and there's one thing I have planned for the weekend, which is nothing. Well, maybe streaming a bit. Maybe when it's not too hot, I just fire up the stream a bit. Your writing is terrible. Don't mind. It's all okay. Orbitsbug. As long as we know what you're trying to say, everything's fine. Yeah. So it's meshing time, and this again, this needs this needs some Unreal magic, and also I don't like this way. There's one reason why I really don't like it doing. No, let me begin the sentence again. There's one huge reason why well, actually, it's more real, but yeah, you could condense it. It's one reason with many bullet points. Why I don't like it doing it this way. Why I absolutely prefer doing your stuff a bit in setting up the base as a blueprint, and also the meshes, and just select them easily in the editor, because we are now going to hard code a reference to an asset, and I think I will still be talking about this. There's a few reasons why you don't want to do this. This is bad practice. But I promised you we'll be doing everything in code and not in the editor, so we do it. But you will see this why this is bad practice. First, we're gonna see what we're gonna do and how we're gonna do it. And I think some of you will already see why this might be bad practice. Because keep in mind, you're not always working alone. If it's a hobby project or a one-man project, it might be okay because you're the only person working on it anyways. But always think about what happens when it's a larger project and you're working on the project with many people that have separate things to take care of. Like you're the coder, you do the code, and then you got the artist who takes care that the meshes are properly assigned. And soon you will see the problem with that. But I have to catch up with chat. So Frankenstein's computer is quite hot too. 2 Xenons at 3 gigahertz, 386 gigs of RAM. Because he can. 386 gigs of memory. Wow, that's a lot. Are you actually? Please allow me the question, and I really mean this. This is not to mock you or anything. This is an honest question. Do you actually use all of that memory? Is there something you're like? Do you have, I don't know, a huge load of virtual machines running? Because then that might make perfect sense. Is there actually something? Are you actually using all that memory? I suppose you are, but for what? If so, for what? I'm really interested. Room temperature below 35. Which ones? Mines? I don't know. No one ever needs more than 640k of RAM. Yeah. No one. No one ever. Especially not on PCs. All right. So, now there's really some, and this is one of the reasons why I don't like this. There's really some Unreal magic, some Constructor Helpers. And Avari, by the way, hi. thanks for joining and welcome. Completely missed to say hello there. It's an old server which you save from save the server, nice. And now you learn neural networks. I think neural networks might. I could imagine. I have no idea about neural networks, how they work, and what kind of resources they need. But I could imagine that needing quite some memory. But yeah, an old server saved from trash. One of the best reasons ever. Congratulations. That sounds like a quite nice machine you got there. GPU would be faster. Yeah, maybe I don't know the specs of the machine, but maybe you could just drop a GPU in or something. If I was a designer and you want to see some coding here, yes, then you're absolutely right, because some maybe a bit too long explanations of too detailed details. We're actually doing some programming here. You're programming C# with Unity so far. Oh, that's good, because if you've actually done C# in Unity already, then quite a few things will either be familiar or make sense quite quickly, because they are quite many things work the same way like they do in Unity. They just have different names. So, but this is something we can't do in Unity. We're currently in the process of creating an actor, and an actor in Unreal is what a game object is in Unity. And in Unity, if you want your game object to have a mesh, so it looks like something, you just plop the mesh component on there. Delta time. Delta time is important. We'll be coming to that. But I don't think we need delta time here today. But we had some examples and why delta time is so important last week. We're currently trying to create an actor, which is your game object in Unity, and in Unity you just slap the mesh component onto a game object, and then you just select your mesh and it looks nice. You can do this in Unreal as well, no problem. But I promised the people we are here for C++, so we are doing this actor completely in C++, nothing else. So, and to actually select the mesh that we want to use, we have to use a construction helper. And this has a static function object finder, and we give the object finder the type of the object we're trying to find, or of what kind of type of object we were expecting to get back once we found what we're looking for. And in this case, it's a static mesh. Not a static mesh component. And now my autocompletion really... Oh, there it is. I was just about to say it leaves me in the dry here. And of course it's prefixed with U because it's derived from an Unreal object. And this time it's not a static mesh component, because the static mesh component is actually the component that's been put onto the actor to do stuff. But the static mesh component has a static mesh that it's going to show, that it's trying to render and make look nice. Oh, what's that? My Discord does updates or what? In the middle of the night, my Discord does updates. Why does it do that? And more importantly, can I cancel the update? No, I can't. Anyways. Oh, we have some green blinking up there. Just don't mind. So yeah, this might be a bit confusing, but when you think about it, it makes a bit sense, because this is the component that actually takes care about making your mesh visible, And this is the mesh that's being made visible and rendered by the static mesh component. So that's what we want to get. And we also need something to put. We need. This is basically the type. This is the type of variable. This one is really nasty, because usually when you define a variable, you go like, you know what? I got an integer that's called I. Call it a day. Everything's fine. And this construct we're just building, this is basically the type. And this is why there's these pointy brackets, because the type is typed. Because this is a static helper function that does some special things, some magic in the background, to then give us back an object of this type. Yeah, so it should work to define this as static mesh pointer and then assigning it. Maybe we actually do this. Franklin is currently working on the topic at work, which let's start here as a survey. Do you use TSC or HPAD as time base on your systems? I don't know. Currently working with highly accurate time in the femtosecond range. Wow. I'm usually not even using... I'm using seconds when we're in game code. Oh, we're actually going down to milliseconds here, but not further down than that. Femtosecond, that's quite a short time scale. And to be honest, I have no idea what the difference between TSC and HPET is. So I use whatever time base comes default with my system. Let's stick to default is TSC. Then I would be using that. Cheers. Throat moisturization. It's the timestamp counter. Oh, timestamp, as in Unix timestamp. Yeah, I'm definitely using that. I'm definitely using. I really like the Unix timestamp. Looking forward to the year 38 it is, when we get the actual 2K problem, which is when all 32-bit Unix timestamps roll over and start back at 0. This will be fun. This will be more fun than the actual year 2000. This will be the real Y2K bug. Looking forward to that. Actually, I'm not, but anyways. High precision event timer. Interesting. So far, I really didn't have any need for high precision timing. Usually, I'm fine with just having the seconds, and in the world of game dev, we also deal with milliseconds, but that's it. Doesn't get quite shorter than this. So give this a name. This is, and we need, remember, we can't just do this. We can save us a bit of time. So we get something. We need two meshes. Remember, we have the cell alive and the cell dead state. And we need a mesh for both of those states. So we call this the mesh asset alive. There's coming something into there. But first let me do this again and copy this for the dead one. So again, there's some text coming into there, and we already had it. If we have any text that's supposed to be used by the engine, we put this inside the text macro. And the text we're going to be putting in here. Here it was just the name. We could give our object an internal name that will be displayed at some places. But since we're using this construction helper, because right now we have object finder, so far it doesn't know what to look for. It just knows we want a static mesh object back, and this is just the name of our variable. So we now need to give it a reference to the static mesh asset we actually want to use for this static mesh, so that we then later can put the pointer we're getting back here, pass it to our static mesh component. Maybe I actually should call this static mesh component, because this is not only the static mesh, this is the static mesh component. And it's really, really good practice to name your variables properly so you immediately know what's in there, because since we're now actually dealing with static meshes and not static mesh components, you might think, okay, you got a mesh in there. That's cool. It's a bit more. It's the thing around that takes care about the mesh being showing up. So we need a reference. We need to tell it which mesh we actually want to use. In the editor, it was just you click on the drop down and you have a long list of available meshes and you pick the one you want to use. We don't have that here. But we still have the editor that can aid us at least a bit. And then we go into the starter content shapes. Yes. Here we have a shape cube. This is the cube we've been using already, and at the beginning of today's session you've seen in the little demo, this is also the cube I've used. And then we also got, there's a sphere somewhere. Here it is. There's a sphere. Look at that. The 32-bit time problem you've talked about is at 3:14 and 7 seconds on Tuesday, January 19th, 2038. Okay, I at least remember the year right. I can't remember the exact date, but the 2038, that I can remember. Yeah, exactly. This is when all Unix timestamps that are still stored as 32-bit values will wreak havoc on all your programs, computers, and systems. And I think at 3:14 and 8 seconds in the morning of the 19th of January, this will be very, very interesting. Shino, hey there. Greet you. Grüß dich. HTTPS will have a big problem. Is that still, unless they don't extend it to 64 bits. But yeah, that will be very interesting. The 90s, that will be a very, very interesting day, because in my opinion, this will be the real Y2K bug day. Not the 1st of January 2000. That was easy. I didn't expect anything to happen there, actually, to be frankly. But that day, that 2038 day, that's 18 years. That's not that far away. This will be the real Y2K bug day that, I don't know, somehow nobody's aware of. I mean, they made a huge fuss about 1st of January 2000, but nobody's talking about 2038. Why? Ja, moin moin. Guten Tag auch. Grüß dich. Yeah, I'm actually German. We're just doing this stream in English because we want it to be available for everyone, not only for Germans, but and English is basically, yeah, everyone knows English. So yeah, we're targeting the international audience. Mother Genesis, hi there. Do we have any YouTube channel where the videos are available? Yes. There is a Devcom has a YouTube channel, and I will get you the link, which is this one. And everything that's happening here on the Devcom Twitch channel of course, including these tutorial sessions, will be forever being archived on the YouTube channel. It's usually quite quick. Also, usually these videos are uploaded to YouTube within a week. But till then, you still have the Twitch VOD. If you just missed it and you immediately want to catch up, you can still watch the Twitch VOD. But usually within a week of the original stream, these videos will also be put on YouTube for yours to watch for, well, until YouTube shuts down. And I don't think this will ever happen. Alrighty, so where were we? We were right here, right. We were about to see how do we get a reference that we put in this text. And it's actually quite easy. When we're, now I got my, I just hit my chat and I don't want that. I need to see my chat. I need to see you guys. I need to talk to you. Where's the, I think it's this one. Yeah, this is our editor. And here we have the sphere shape, and we have up there the cube shape, and you just do right mouse button in the editor on this. If you can see it, well, let me make this a bit larger, magnify this a bit. You can see up here the first line. It's just the name. This is the one we could rename. We can do anything with. You can put anything you want there, and on the second line it tells you what it is. So if I go into another folder just for demonstration, like here, we can see those are particle systems. Neat. I like particle systems. They always look nice. Here, it's materials. So there's, hold on, this is the whole starter content. This is when you create a new Unreal Engine project and you say, yes, please do give me the starter content. This is everything. This is the whole thing. This is everything you get. There's quite something in there, so you don't have to take care about having some initial materials, meshes, shapes, or whatever. So you can just prototype away and write your code, and worry about how it's going to be looking like later. So, and we got our sphere somewhere here. There it is, shape sphere, and this is a static mesh. Perfect, because that's exactly what we need. We want a static mesh, so our static mesh component can then somehow display this. So hit the right mouse button, and then there's it, and then copy reference. In this large menu you get when you click the right mouse button on the static mesh or any other asset for that matter. It doesn't only work with static meshes, but in this case, we need one, but it works with everything else as well. You get this one, copy reference. And that's the one we hit. And now we got a reference, a usable reference, in code, usable string representation of a reference in the clipboard. And if we now go into the code and I hit Control V, it puts this into there. And this is the exact reason why I'll be putting a comment here. This is bad practice. Don't try this at home. Make this assignable via the editor. Because reasons, and lots of them. Wink smiley. I will actually tell you the reasons. One, if you're the only person, if this is your hobby project or you're a one-man show, you're doing everything yourself, you can do this. I still recommend not to do it. This would be reason number 2. But before we can talk about reason number 2, we have to talk about reason number 1. Imagine this would be a larger project and you're the coder you're the one writing all this nice, shiny C++ code. But on the other table, your colleague, he's the artist, and he's actually the one who makes all these nice cubes and spheres. So he's the guy who builds those nice static meshes that in the end will make your game look really cool and nice and like eye candy. Because while gameplay is very, very important, gameplay is the most important aspect of a game, your eyes are playing with you. Oh, not with you, but with you. You know what I mean. So it also has to look a bit nice, unless you're doing Dwarf Fortress. That I don't know. That does it with ASCII graphics for some reason. But well, there the gameplay is what catches you. Anyways, you want your artist to be able, if he built his super nice static meshes, and you wrote your code, and now he wants to put his meshes into the game so they look nice. That's why he built them. You can't expect your artist to dive into your C++ code and find the right place where you got this reference stored to the mesh, to the asset that's being used, and then change this to whatever the right reference is. You really can't. And even if he can, even if there's artists who know a bit of code, who have no problem of opening a code file, they're not afraid of it, and they're not running away screaming loud, and they can skim through and they see, yeah, okay, this is the path to my static mesh, I just put it in here. He will not. Yeah, exactly. He should not. Your artist really should not have to open up your C++ file. So this is one reason why this is really bad practice. And I'm only doing this so I have something I can move away from for a second to say hello to UR3. Now I know. Haha! I'm still not sure why there's two leading zeros. Maybe it's UR003. Oh, UR003. You're a secret agent. Now I got it. You're a secret agent. You're UR003. Okay. All right. Anyways, hi. Nice for you to join us. So this is pretty much the number one reason why this is super duper bad practice. And I'm not only suggesting you're not doing this, I'm begging you not to do this. Because if you got your artist and he wants to change the meshes, he's not supposed to have to dig through your code to find the references. The only reason why I'm doing this way for now, we might change this later. The only reason why I'm doing this is because I promised you we'll be doing this actor completely and only in C++, nothing else. No editor, no blueprints, no convenience whatsoever. I promised you this and I stand to my promise. We're doing everything by hand in code. This is the only reason why we're doing this. And also it doesn't hurt to know these things exist. And it especially doesn't hurt to know how these things work. Because basically, when you're doing all these things in the editor with clicky clicky, pointy clicky, well, it's kind of making games is kind of like a point and click adventure. You just point and click the right things in the editor and hope it works. This is basically what happens under the hood. If you create a blueprint in the editor, and in the blueprint, we have just so you know what I'm actually talking about. Let's pull this up. I think we have some blueprint actor left over from last week. Yes, or even from the week before. Here we got our test pawn. This is a blueprint. This is a blueprint actor. And this is where you make the blueprint actor nice and shiny and look like things. And when you say add component, and then you add the static mesh component here, not sure if you can see this. If you add the static mesh component, and then you go over here, and you just select the mesh component, like the shape sphere, and all of a sudden you got this little ball here, that's a sphere, and that's your static mesh. This is nice and convenient, and works super fine. And this is actually what happens under the hood. This is what the engine does. If you select all these nice colorful options in the editor, this is actually what happens. Under the hood, this is called, and then there's something else called the attachment of the component actually to your actor. We still need this. We still need to have to do this. So this is called, and this is being done, and the attachment thing is being called, and all these things are happening under the hood to make your actor like this and then work. And I think it's super important to know these things, to understand what's happening under the hood. So the black box is not so much a black box, and the magic is not so much magic anymore, because you know all the tricks that make the magic work. In my opinion, it's quite important to know and understand these things. Like a point-and-click adventure, yeah. You're a very bad secret agent. Your cover is now known. I won't tell anyone. I promise you. I promise you, I won't tell anyone. I will keep this. I will keep this for me. I will cheer you to this. Cheers. Yeah, and so there's actually two rather good reasons why we're doing it like this. To show you, because I promised you, and so you understand and you know what actually happens under the hood when you select these things in the editor. Because sometimes you might run into problems that if you know how these things work in the background, you will find out what the actual problem is quite better, and then you can do something against it so it works. Unreal Island. Yeah, that sounds nice. I mean, we got Unreal, we got Unreal Tournament, Unreal Island. What would Unreal Island be? What kind of game would Unreal Island be? Well, it has to be some first-person-y thing, because that's where Unreal comes from. Unreal Island sounds nice. But yeah, so we got for our Alive mesh, we got the sphere, which is actually wrong. I want this sphere to be our dead mesh. Dead mesh? Jesus Christ. Unreal and Monkey Island. Oh. A first-person Monkey Island game made in Unreal. I don't know. For some reason, that doesn't actually sound like that much of a bad idea. So, we put the sphere mesh into our dead mesh asset, because I just want it like that. You can do it however you want. If you're doing this alongside, you can do whatever you want. You can pick whatever meshes you want. Again, in case you missed it, in case you stumbled in a bit later, the whole code I'm building here with you will be made available to download once it's done. Once this little implementation of Game of Life works, I will make the whole code available so you can download it and play around with it a bit. So, and you can change these things. You can swap them out or whatever. I think what I would like to implement with you guys is that when everything works, and this works like that, that we find a way to make these settable from the editor via a blueprint. And if they are not set, we use these as a default. So then we still have our sample code, how it's done in code, but you can also more conveniently set it in the editor or something. Frankenstein is known for giving very good ideas. Okay, cool. So where's my proper editor window? This is on that side. That's cool. This is where it belongs. So, and now we need the same thing for the cube. We just copy reference, go back into the code, hit Ctrl V, and there we go. We got our shape cube. Well, okay, so now we have our static mesh component. We have two static meshes that we could actually assign into the component. So let's do that. Now, wait. We can't just put those in. Because remember, we want it to be able to switch. We want to be able, if we click on it, it should toggle its alive state and should toggle between alive and dead. So we need to save these references. We need to save these somewhere, so we can later then just pick up our reference, our pointer to our object, and just set this. Because during runtime, you can update the mesh property of the static mesh component. You can, at will, put a reference to a different static mesh in there, and then that other mesh will then be displayed. And this is how we will toggle the visual style between alive and dead. So we go into our header, and we put two properties in there. And that's a U static mesh. And we got, and it's a pointer. Again, this is a huge complex object, so we're only getting a pointer to this. And this is our alive mesh. And then we have this again, and that's our dead mesh. And again, you can see those yellow squiggly lines, and the very sharp eyes of you might already know why there's a yellow line under there. And it's of course because object member can be garbage collected at any time. Don't worry, I won't repeat this way too long monologue about garbage collection. If you missed the beginning, just watch the VOD or later on YouTube, because I explained what the problem is, why this is bad, why this is something we don't want, and why this, since I'm lazy, I just copy paste this, is the solution to our problem, and even the yellow squiggly line is gone. So our meshes won't be garbage collected, they won't be thrown away by the bad garbage collection. So what we could now do is, we could say, okay, well, look, our alive mesh is the mesh asset alive, and our dead mesh is our mesh asset dead. And for some reason, my IDE tells me, nope, this is not how this works. This is weird, because this is how it should work. I did put the asterisk there, and it's telling me, look at what's telling me. What do I do if I want something to be garbage collected at a later time? I will just delete my reference. If I want the object to be garbage collected, I will just overwrite. For example, this is my reference. This is the reference I have to the object. And two things can happen that will make this object then actually be garbage collected. Either my object here that is holding this reference and using this object is being destroyed itself. So with my object, the reference goes, and then both will actually eventually be garbage collected. Or I can just overwrite this reference with either another object. I can create a new object and save the reference here in this pointer. Or just put a null pointer in there. Basically, literally 0. In both cases, the reference to the object I just created is gone. And since Unreal, because we decorated this with the U property thingy here, Unreal can keep track of if you still have a reference to this object and who else has and everything. And then the garbage collection will eventually see, okay, this object is not referenced by anyone anymore, not even you who originally created it. And then the garbage collection will put it away and free the memory. So TLDR, just overwrite your reference with a null pointer or another object, and the old one, if not used any place else, will be garbage collected. Because if you pass this reference to another object that then does stuff with it and itself keeps a reference, then it won't be garbage collected, but it's still in use. The garbage collection only dumps stuff that are not in use anymore. And this is why this is important. So Unreal can keep track that we're still using it. And it doesn't know it. And this is why it's a problem when this is gone. Because then Unreal doesn't know that we have this reference. Again, for a longer explanation, watch the first something earlier tonight. I held a rather long monologue about why, how, and what. And if there's still any questions, please feel free. Either tweet me. Below me, there's the two handles. The first one, the real Hellcat, that's me. That's my personal Twitter. The one below that is our studio Twitter. Above me, there's the hashtag #AskDevcomTutorials. Feel free to use any of those to tweet to ask your questions if there are still any. And I will see that we get it covered and answered here. Or if you're rewatching or first time watching this on YouTube, put it down in the comments. I will regularly check the comments if there's any questions that should be answered, or just here in the chat. I mean, that's the most easiest way. Just be here, be with me live while we're doing this, and just drop your questions in the chat like Monogenesis just did, and then we can address them. So yeah, but gotta find out why this seems to be not how it's supposed to be. This is static mesh. This is static mesh. It's also a pointer. Maybe I need to save this. Sometimes saving helps, but not in this case. Can Unreal do zip memory like Linux kernel? Whoa, I'm not sure. I don't know if there's. I don't think there's functionality like that out of the box. But you can add it since you have access to the whole engine source. You can actually check out the complete engine source from GitHub and can compile it yourself. You could add something like this. You could. I don't think it has, because constantly compressing and decompressing would cost you a lot performance, and for games, performance is more important than memory usage. So using more memory is something you're completely okay with if it saves you performance. So I don't think. I also wouldn't know why it would make sense. I don't think it has. But yeah, as said, if you need it, if you want this, you can easily add this, since you got access to the whole source code. Oh, okay, I know why. I just had an idea. This is I said that we're getting back, when we're doing this, we're getting back an object of this type, which is not completely right. Sorry, which is not completely right. When using the object finder, we're getting actually back a data structure. This doesn't return, and this is actually what the error message says. See the measures it alive. Oh wait, no, this is it's just only my comment. Why is this only my why? Oh, because here's the error. Can I sometimes use the mesh from is that an L or an I? I don't know. Sometime of value of type yada 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 yada. Because we're getting back a data structure. We're getting back a data structure, and this data structure has a property called object. And this property of this data structure, can we peek into that? No. Can I? Nah. Okay. This data structure has a property called object, and this actually holds the object we requested it to find and to instantiate for us. So if we just put this there, then it works. It is CPU heavy, it would be saving bandwidth on the memory. Yeah, but I think the time you spend, the performance loss with compressing and decompressing would be higher than the saving on the memory bandwidth. Well, one would need to try. One would need to actually implement this and then run a few benchmarks with compression enabled, without compression enabled. This is just guessing into the blue what I'm currently doing in regards to the zip thing. Well, feel free to add it. I would actually like this just because it's possible. And I'm actually planning on doing something a bit similar. I don't want to compress my memory, but I want to checksum it because I want to implement something to make the basic cheating via memory editing not impossible. It's not possible to make these things impossible. Whoever pretends these things can be made 100% secure or hacking or cheating can be made impossible, lying. Has no idea what's talking about. There's no such thing as 100% secure in computer science. It doesn't exist. I just want to make it a bit harder to cheat in the game by just editing the memory. You know, classic cheat engine where you know, there's my gold coins. I just put another number in there and then I have lots and lots of gold coins and I'm happy. I actually want to counter this a bit. Mostly because I just want to take up the challenge and want to do it. Not because I really feel the need to make cheating like this harder. But I want to take up on the challenge to actually make this. So I actually need something that checksums or compares and does thing with your variable's memory to see that something has been tampered with. Yeah. So we couldn't just do like this. We could now just say, okay, well, here we have our local property of our class, and we just put the object that the object finder instantiates in there. Again, we're good coders. So what we do is we check for possible errors because if this didn't work for some reason, this might already be crashing because there's nothing in there, or we didn't even get a data structure back, but rather a null pointer or anything. So what we're doing is we're checking if we actually got a usable object back. And all my windows, I need more monitors. I really need more monitors. So we just enclose this in a little if. We just check if we got anything back that doesn't evaluate to false. This works because if there's a null pointer in there, a null pointer is a 0 evaluates to false. If, well, you get the point, right? So, and since we're good guys, we like to pretend we know what we're doing. We're doing some error handling here, and we could even, let me see if I find, because for my life I can't remember the syntax of that thing. Let me see if I find a, there it is. There I have something. Look at that. Because what I like to do is to, in case this didn't work, we're gonna be printing out an error message onto the debug log console, which does this little UE log macro here, and this is our constructor. So we do it like this, and we say failed to find mesh asset for a live state, and then we make this lowercase. Solution to the problem with cheating memory would be signature of the contents in the ROM. Yeah, this is one of the ideas. I always do a bit more. I think just the signature, not sure if that's enough. Maybe I want to do some more, but yeah, definitely a signature. That's one thing that needs to be done. But maybe even scrambling the values a bit, so the values are not even in their literal form in memory. So like if you have a 1, like because you have 1 gold coin, there's, I don't know, B578 or something instead of that. So which already makes finding the values a bit harder. But I haven't really thought this out yet. This is just a general idea. I have a few ideas what I want to do, but there's a lot of trying and experimenting. And who knows? Maybe I'll do this live on stream. You rather ask yourself, what should the software do if it finds a change? Ideally, just revert it. And maybe print out the, I don't know, some neat little message like, hey, you're tampering with my memory contents or something. I don't know. Because I like these little thingies when the game detects you're doing something and you just getting a neat, maybe sarcastic or ironic message. Like the one time I was digging around in code where you weren't supposed to dig around because it was compiled code and it was originally even encrypted. So we had to decrypt it, and then we were fiddling around with a binary, and we actually we found a spot where there was the a little text like, "You're not supposed to be here." That was quite nice. I like these things. This is the little things only a few people will see, but I like them. So, we didn't find our mesh asset for the dead state. So, or like Ep.3, we do not get iron if it's cracked. Yeah, something like that. Something like that. Okay, error handling. Very important. This is something most people overlook when they are writing code. Always do your error checking and error handling. I have one function in our actual project that's like 80% just checking for errors and responding to them. So we still haven't set the mesh into our mesh component. And we could just what I could do. If I peek a bit, wait. What I could just do is I could say oh, come on, auto completion. Why you hate me? Oh, no. Okay, but well, still with static mesh. Well, I could say static mesh component set static mesh, and I could just put my dead mesh in there, because by default the cells will be in the dead state. I could just do it like that. The problem is later on, and we just think a bit ahead now, later on, when the cell is supposed to change its state, I will again have to call this and put the mesh in there. And maybe someday I want to change things, that I have to do different things or more things, or I do completely different. So I would have to find all the places where I call this set static mesh and I put the dead mesh in there. So to avoid duplicate code, because this triggers my internal copy-paste detection, to avoid duplicate code, because usually this is a best practice. It's at least a good practice. If you know you have something you're going to be doing or using more than once, pull it into an own function and call that function. Because if you ever need to change this, you just have to change this one function. Again, if I would set the mesh here, I would set it at some other place and some other place. And if I want to do different things, I would have to find all these places and change the code that makes the cell look dead. So I only want to have to take care about one place that I would have to change if I want to change it. So we make a set cell dead. And in here we can say static mesh component set static mesh. Hi, what am I coding? This is a little sample example project program, whatever you want to call it. We're gonna in the tonight, and I think we're gonna be needing at least 2 sessions to finish this, because we're almost at the end already and we haven't even finished our basic actor yet. This will be a small implementation of Conway's Game of Life, and just a very, very quick, because I extensively showed and demonstrated this at the beginning. This will basically be something like this. You have a grid, and these are cells, like cells in your body or any other organic life form. And currently these are all dead. And then you can click them, and then they become alive, which will look like this. And then we have a nice little pattern down here as well. And then you start iterating through all the generations. There's a set of rules that determines if a cell keeps living, dies, or comes alive when it's dead. And then it's just iterating based on these rules and calculating generation after generation. And there's also nice things like this one, and I really like it when it crashes into the little box down there. And off we go. And it looks like this thing is moving, but actually there are cells coming alive and cells dying, again, which is based on some rules. I did a quite lengthy explanation of what this is going to be at the beginning, so feel free to check out the VOD. And this is basically what we're building at the moment. And right now we're we're building the basic actor. So these cells you've seen, that are these little tiny spheres when they are dead, and these huge cubes when they're alive. That's an actor, and we're currently coding this actor, so we have all the functionality we need to then eventually make a field out of it and iterate through the rules to calculate the next generations and everything. So we have a set cell dad. So we also need a set cell mother, because mother and dad, no, dad and alive. Oh, and I didn't set anything here. Why is this gray? Okay, this is just a display bug of my IDE. This shouldn't be. So we set the dad mesh here, and then we set the alive mesh there. So now we have two conveniently callable functions that, should we ever have the need to set the cell to a dead or alive state, we can just call them from wherever we need. And if we should ever decide we want to do different things to set them alive or dead, we can just change this one place here, and everything else just already does a proper job. So this is red because, again, remember the last two sessions we made, every function you declare for your class, you also have to declare in your header file. So we just say create declaration. We could also do this by hand, but this is just so convenient. And here they are. There are our functions to set the cell alive or set the cell to dead. They are currently public. I'm not sure if we need them public, or if we, you know what, for now we just put them private. If we should see a need for them to be callable from the outside, we can always change this. But for now, let's just make them private. So then we can just call set cell dead here. So what have we got? Let's pick up inventory. We have our root component, so we have a scene component that we can attach other scene components to at all. Then we have our static mesh component, which is a special kind of a scene component. We have our meshes for alive, our mesh assets for alive state and for dead state. And we also checked if we actually found them, if everything worked. And then we could, and then we just set cell dead, sets in our static mesh component. This is the one we created up here because this is a property of our class. It's available for every function to access. And we just call the set static mesh, and in this case we're setting the dead mesh. So at this point down here, we pretty much have everything we need for our actor to at least look like something. It just doesn't, because if you remember last week, we still need to attach our static mesh component to our root component. Should we comment it? No. So, okay. So, attach our static mesh loaded static mesh component to the root component, so our mesh actually shows. Does that make sense? Yeah, I think this makes sense. So and this is a bit confusing because you're not telling the root component, hey, I got something to attach to you. It's actually the other way around. So we have to tell our static mesh component, I want to attach, setup attachment, I want to attach you to our root component. Yeah. This should be it. I hope. I mean, there's only one way to find out, and that's pulling this thing in the scene and trying. I'm just checking if there's anything we missed, but so far not. All right, so let's save this. And let's run this through the compiler. Let me find the right window. And let's hope this compiles. I mean, there might still be something really, really bad hidden in the code, some typo, something I did so wrong that even the compiler doesn't like it. Well, let's see. So maybe we'll be having an actor that we can at least, let me tidy this up a bit. Okay, why didn't I hear any? Oh, because I muted that thing. Okay, because I really like the sound. These I don't know. They always the sounds Unreal makes when it plays the I'm compiling or I finished compiling. These sounds always remember me of Star Trek, and I like that because I like Star Trek. So here we got our cell actor. In theory, if we pull this into the scene, we should get something. What should we be getting? We should be getting a sphere, because we, as at that, we took the sphere and then we put this into the dead mesh and said that, we should basically be getting a sphere if we pull this into the scene, and look at that. So many spheres. So our actor works. So this is now almost 3. This is 2.5 hours of work. Okay, there's a bit explaining and talking and chatting involved. If you would have just done this without chatting, it would have taken you, I don't know, maybe 20 minutes, half an hour or something. For something that you could have done in the... We could do, you know what? Just for comparison's sake. Look at that. We've written all this code, which takes you some time, and sometimes, like, when you're like me, you don't remember all these things. You constantly have to look up the documentation and the reference, so you actually know what the function... Or sometimes, or quite often, actually, the auto-completion helps a lot already, because you kind of know what you're looking for, and in the suggestions of the auto-completion you will find, this was exactly the thing I was looking for. This was the droid I was looking for. So what did we do? We didn't do this. This is always there. This is part of the auto-generated base file Unreal creates for us. Then we created our root component. So we have a root scene component we can attach other scene components to in the first place. Then we created our static mesh component, because we want our actor to look like something. And to have it look like something, you need a static mesh. To have a static mesh, you need the static mesh component, because that takes care about showing you, displaying, rendering your static mesh. Then we fetched, based on these references, we fetched 2 assets, which by coincidence happen to be static meshes. And we stored them away, and eventually we set one of the meshes into our static mesh component, so the component actually knows which mesh to display and render. And last but not least, we finally attached our static mesh component to our root component, so that thing actually exists. Because if I comment this out, it's only this setup attachment line that I commented out now, and I recompile this, and we pull our actor into the scene. As you can see, you're not seeing anything, because when we look at the list of components, we see our cell actor and we have our root component, and then nothing. Because even though we created everything, we properly created and set up everything, we just didn't finally put it onto our root component. So put this back in. Compile. So pull this and nothing happens. Okay, let's try this again. That's a problem. Sometimes the reload doesn't work. Did I do something? Did I maybe forget to save? No, I did not forget to save. I save again. Setup attachment, root component. See, this is... I am in the right editor, right? Yes. Ah, see? I don't know. For whatever reason, maybe I did for near, but it shows the tabs in the... Well, doesn't matter. It works now, and... Oh, and by the way, but that thing's... Wait, that thing's public, isn't it? Because it's still not showing up in the list, which is... Oh, I think I know why. Remember, we also had this phenomenon last week. This is, see, this thing's selected. This is our selector, the 19th, by the way. And we still got our instance here of our actor, and we got the root component, but still, look at that, still no mesh component. It's weird, huh? Because it's there. The mesh wouldn't show if it wouldn't be there. But it might be because I just said, yeah, look, this is a U property. This does not, even if it's public, this does not automatically show these properties in the editor. So if we put a visible anywhere option to this U property, now it should show up. Because let's first see if this works before I elaborate on what I think went on. Again, we changed something in the header, then it always takes a bit longer. And look at that, here it is. Now we got our root component, and as child, because attached to our root component, we got our static mesh component. Again, I have no idea why it doesn't use the names we put in there. It should have, but it doesn't. But then again, it also doesn't really matter. So we got our static mesh component. Now it's showing up. And the reason why it's not showing up, even though this is public, we made this public. We declared this as your property because remember, if we didn't, now it's completely broken. Okay. Oh, because I deleted too much. I deleted the U as well. Now it works. And now it gives us the yellow squiggly line warning us, dude, this might be garbage collected. So we put the U property in front of it to make Unreal aware of this reference to an object, so the garbage collection won't throw it away. But this will not automatically make it visible in the editor. By default, stuff that's yours will stay yours. It will stay, well, it always belongs to you, but I think you know what I mean. Unreal doesn't just show everything in the editor, even if it's public. Because for several reasons, because most things maybe they don't need to be shown in the editor, or sometimes you don't want to. And if you don't want to, you just put the empty U property there, because that only makes Unreal aware of your property, of the reference we hold here, and that's it. You have to explicitly tell Unreal, I do want this to show up in the editor. And there's several ways you can do this. Visible anywhere, I think you can only see it. You also got edit anywhere. Then you can actually change this and change around stuff. But since the actor is, it only exists once it's spawned, We put this visible anywhere in there, so Unreal knows it's supposed to show us. I'm not sure if I think we can even. Yeah, look at that. We can even change the mesh here. So it's not read only. You can actually change this, but it's only for this instance. Like if I drag some more of these in here, and I select this, and I give this. I don't know. What do we have? What's trim 90? Oh, that looks so tiny. White capsule. Yeah, see, this looks fancy, and this one. Oh, yeah, the good old default chair. Everybody knows this one. Everybody knows the chair. So, yeah, you can edit this in the instance, but it's only affecting this instance of this actor. Because in code by default we said the other thing. And this is why this didn't show up, because we have to explicitly tell. I'm not sure if you can make this read only. Can we make this? Is there because maybe you want it? You can in blueprints you can make it read only. You know the default monkey or Tcan. Yeah, that's the Tcan is 3D Studio Max, I think, or maybe even others, because the Tcan is quite common, and the monkey is Blender, I think. The monkey is Blender. We can put. Unfortunately, I don't have a Tcan mesh. Or otherwise, we could even set the Tcan as default here. But for now, we set the sphere as a default. So let's compile this and see if I destroyed anything. Let's delete those. Let's hit the Borg cube again. Or actually, this. Did you guys watch Terminator 2? I mean, this icon up here. Don't you think this looks a bit like the main CPU? They remember in Terminator 2 when they had the Terminator in front of the mirror and they were opening his head and they were taking the main CPU out. I think this looks quite like the design of those CPUs. But then again, Terminator 2 CPU, that sounds weird. I just call it Borg cube. It also goes quicker from the tongue. So, can I pull this in here and everything still works? The problem is Unreal sometimes has problems reloading things. I think this is one of the reasons why after the recompile before it didn't show up, because sometimes the editor has problems reloading everything. So let me close this for a second and reopen. So just to make absolutely sure whatever happens is actually the current version, the current compiled version of the code. So if this works, then we're happy and everything works. So here we are. Also got my Game of Life map here, the little empty one, and I pull my actor in there. Yeah, and it still works. Nice! Ref Roadpest, your timing is again quite perfect, because we are coming to an end here as well. Because I think this is, there's quite much more to do. I think we're going to be needing 3 evenings, so 2 more. Because now we got our basic actor. And Ref Roadpest, have a nice evening yourself. Nice for you to stop by, to check in. Check in and fly out or something like that. Yeah, see you around. And yeah, we're coming to an end here soon. But for those of you who say, come on, it's so early, this will not completely be the end of the day, because we'll be having a little, I like to call it after show party. I will be raiding our studio channel when we're finally done here. And if you want, you're more than welcome to hang out with me a bit more there. That's you. Always there at the end. Yes, always there till the end. So if you still have some time and you're interested, feel free to stick around, because we'll be raiding over to our studio channel, and there we can hang out a bit. I will play around a bit more in Unreal Engine, but in our actual project, I will be working on our actual project a bit. And for the things I do, this also has to do with C++. So if you want, stick around. And we can just talk a bit more about basically everything you want, especially Unreal and C++, because as said, I will be working on our actual project a bit there. And we can just have a nice rest of the evening, and also talk a bit more about like off-topic stuff that really doesn't fit in here. So what we have now is our... but I wanted to show you is the difference of doing this in a blueprint. So we got our C++ code here. Again, we get a root component, we created a static mesh component, we fetched the mesh assets, we put the asset in our static mesh component, and finally attached the static mesh component to our root component. And all of this only to have a sphere in the level, in the scene. So if we would do this, and this is exactly, I've said this so many times already, so bear with me when I say it again. When I work on my actual Unreal projects, I don't do it like this. I don't create everything purely solely in C++, even though with this project we'll be ending up doing this, because why not? Because we can. But what I usually do is my actual code, my actual business logic that I want to run, I put it into a component, which in the course of this little project we will also be doing. We will also be creating an actor component that we will then put onto, and this is something new, this is something we only a bit talked about, but we'll put this onto the game state, because we have to have a custom game state and a custom player controller, and for this we have to have a custom game mode where we can set these things, all things to look forward to. And Arak Anya, hi there, have a wonderful evening and thank you for the raid. Hello, all you wonderful people coming over there, and make yourself comfortable. Hope you have a nice evening. I'm pretty sure you had it so far. And yeah, hi. And thanks. Yeah, so we did all this just to have an actor in the scene. And oh yeah, I was about to say why I usually don't do it like this. Usually I create all the actors, the base actors, as a blueprint, and I put my actual code into a component, and then I just slam the component onto the actor and just call the functions I exported into the blueprint from this component to run my actual code, because it's just so more convenient. Because we did all this just to have our actor showing up here at all. And if we would have done, and we're just gonna be demonstrating this quickly, we say we want to create a new blueprint and we want to create an actor, and we call this just demo sample about to be deleted actor, and then we open this up, put it neatly like there, and we add our static mesh component. This is what we did in code. Did I mistype? Yes, I seem to have mistyped. This is what we just did in code. Remember, we add our static mesh component. It's automatically attached, so we don't have to take care about the attachment. It's just attached to our default scene root there. and then we can say, yeah, and you know, in this case, we want, so it looks a bit different. We want a cube mesh, which looks rather big. So there it is. And that's it. Compile, save, drag into the scene. That's it. So what we did the whole evening here in our code with quite some, I mean, okay, this is granted, this is a bit error handling. Yeah, but it's just a few clicks and you just got your actor. And this is why I like to combine the two things. I like to create my actors in Blueprint, and then in the event graph you can attach your component. We did this. Wait, I can actually show you, because we did this last week. We did this here. I think it was the test pawn 2. Was it? Well, wait, we had, oh, did we? No, we didn't delete this. Where's the one? We had one where we, remember, where we had this call number, this do something with numbers thingy? It's gone. Oh well, it's not that much of a problem. So you can see it looks a bit like this. Oh yeah, here, set move direction. Do we still have the? Yeah, I think we deleted it. I think for some reason to demonstrate something, I deleted the do something with numbers. But yeah, this is usually how I do it. Just put your meshes and everything on here. Put your code into a component, and our pawn move. What's here? Pawn move. This is a component. Not sure if we can. I think the tooltip is a bit large enough. This is pawn move component. This is the one we've written ourselves. And then you can just call your C++ functions from the blueprint and do your actual business logic in your C++ functions. But it's way more convenient to set it up like this, because while you can do it like this, it's way more work like this. And if you're remotely like me, if you're an IT guy, you're super lazy, you like to avoid work, and this is work, and this is at least a quite significant amount less work. Yeah, and this is why I usually set up my stuff, the basic setup. The base is always a blueprint, while my actual business logic is then in my C++ classes that I just call from the blueprint. It makes life just, it's quality of life, basically. But then again, your mileage may vary. You can say, you know, all this clicky stuff and not knowing where do I need to click and where do I find whatever. This is not me. I'm way faster just knowing what I have to type and just typing it out. Again, this is completely personal coding style and how you do things. I can only speak from my experience. So I see that the actual power is combining blueprints and C++. And I really I've talked about this already. I really like how these things work together, because they really work very nicely together. And combining these two actually gives you quite a lot of power and the ability to do quite cool stuff. So, are there any hard restrictions on the event graph method of coding? Things you can only do in C++ that you can't do in nodes and connections? I don't think so. As far as I know, everything you can do in C++, you also can do in blueprints with this visual scripting. There have been games that have been completely done only in blueprints, no C++ code, not one line, just blueprints. So I'm not aware of any restrictions. To my knowledge, everything you can do in C++ you can do in blueprints, because all the all the the Unreal, all the Unreal API functions that you might be calling from your C++ scripts, they are also exposed to the blueprints. So everything, I mean, you see there's so much stuff you can do here. So everything Unreal API wise you could call from your C++ scripts, you can also call and use from blueprints. So yeah, long story short, I'm not aware of any restrictions, no. It's completely up to you if you do your project completely and only with blueprints, if you do it completely and only in C++, or if you're like me, you just use both and see what gives you the best result or the most convenient result or anything. I personally like to combine the both. And you're welcome. Thanks for asking. If there's any more, I don't know, if you're not sure if you're interested in catching up with the VODs or the recordings on YouTube, if you've got any more questions, up there is a hashtag. You can use this at Twitter. Down there are two Twitter handles. One is mine, one is the one, the first one, the real hacker, is mine, my personal one, and the other one is the one of our studio. Also feel free to tweet at those if you have any questions. And if they fit into the topics we're talking about here, I'll see that we'll get it covered here. And if not, we'll cover it someplace else. But I'll see that we get it covered. Alrighty. So I know I know that this is it for today. Let's delete this guy. This is it. This was episode 3 of the ongoing Devcom Tutorials series, Coding for Unreal Engine in C++. I hope you enjoyed it. I hope whatever I told you today will and can be of help and or use for you. Next week we'll be continuing. Next week we will make this thing clickable, because if you remember it's even this one, right? Oh yeah. Need to scratch my knee before I can touch my mouse again, because this is how it's supposed to be looking like in the end when we're done. And these thingies, they are clickable. When you click them, they become alive, so they become the cube. And you click them again, they toggle back. This will definitely be the functionality we will be building next week, so that these things are actually clickable. And there is a bit more to it than you might think, because it's not only enough to have code that handles this in our actor, we also need to do a few other things. What these things are and how they are done, next week. And for today, if you still have some time left, and if you say, oh, come on, I want to talk about, I don't know, Stargate with you, or just about random stuff, and I want to go to bed right now, then stay put, because I won't be going anywhere, at least not far away. I will just be hopping over onto another channel, and you don't even have to do anything to come with me. You just have to stay here, because I will be raiding this channel over to the other one, which I just have to, wait a second, now I need to do some weird multi-OBS, multi-stream magic, because I have to fire up the other stream, which hopefully just happened. And then I can raid you over, and if you want, you're more than welcome. I would wait for Twitch to actually recognize. Yes, the other one is already live. Wonderful. So, because I can now raid you over to the other channel, and if you want, you can. You're more than welcome to. I don't know. Let's make another hour or so. Just hang out and talk about stuff. I will be working in Unreal. Still, I will be working a bit on our actual project. I will be having this open and working a bit on this, and during that we can, well, talk about stuff. My name's not Kirk. Oh, there was the time travel episode where they were caught in Area 51. Oh, that was a great episode. My name's Kirk. Your name's not Kirk. Yeah, you're right. You got me. My name's not Kirk. It's Skywalker. Luke Skywalker. Yeah. Great scene. Great episode. Great series, actually. So, where's the outro? Let me see. This is the one. Because I'll be playing you the outro, and I'll be setting the rate hot. And yeah, I would be very happy to see you over there at the other channel. If I won't be seeing you over there at the other channel, have a nice weekend, and see you next week. Bye-bye.